Researchers in the UK think they might have found the best evidence yet of life outside our solar system. They're about 99.7% sure they've picked up chemical signals on a nearby exoplanet that only living things could create. If this is real, it could change everything about how we see life in the cosmos. Earth might not be the only place where life got started. We've always wondered if we're alone. For ages, there have been stories about strange lights, flying saucers, and alien encounters. But now, we're not just guessing. We're using powerful telescopes, satellites, and science to look for life. Instead of wild stories, scientists are checking data, searching deep in space for planets that could support life and signs of living things. Governments have started releasing some info about UFOs. But real proof of aliens has been hard to find. So, instead of chasing UFOs, scientists are looking at planets around other stars, called exoplanets. These space telescopes can check out the air around distant planets. By watching how a planet dims the light of its star, they can figure out what gases are in the air and look for ones that might come from living things. Exoplanets are all different. Some are huge gas planets with air we couldn't breathe. Others are super hot or frozen. But the interesting ones are in the habitable zone of their stars, where there might be liquid water. Since water is needed for life on Earth, these planets are the best places to look. One exoplanet, K2-18b, is really interesting. Earlier telescopes found it, but now the James Webb Space Telescope, JWST, has given us a much better look. It's in the habitable zone and seems to have complex chemicals like methane and carbon dioxide. These aren't proof of life, but they're part of things that support life on Earth. What's really exciting is that they might have found dimethyl sulfide, DMS, a gas mostly made by tiny sea creatures on Earth. It's not confirmed yet, and they need to check the signal better. But if it's there, it's a big deal. The JWST can see these tiny chemical clues by filtering starlight through the planet's air. It's hard to get direct pictures of exoplanets, so scientists use stuff like spectroscopy. This means studying how molecules absorb or change starlight. K2-18b goes around a red dwarf star, which is smaller, cooler, and more common than our Sun. These stars can be a bit crazy, sending out flares that could mess up the air around planets. We don't know how stable K2-18b's star is, and that could affect whether life can survive there. The JWST is super sensitive, so scientists can do more than just find chemicals. They can also check the air temperature, clouds, and where chemicals are located. Some people think K2-18b might be a Hycean planet. This means it has a thick hydrogen atmosphere and a deep ocean. If there's life in that ocean, it could make chemicals like DMS that float up into the air. Finding those signals from so far away is really hard, but it's why K2-18b is such a good place to look for aliens. We have to be careful, though. DMS could be made by non-living things, like chemical or geological stuff we don't know about yet. Scientists are being honest about this. They don't have proof of life yet. They need to rule out other things, like problems with the sensors or weird stuff happening in the atmosphere. They're still checking the data to make sure the signals are real. Besides DMS, the methane and carbon dioxide can tell us about what's happening on K2-18b. On Earth, these gases can come from living or non-living things. Finding them together makes scientists wonder how they interact and if the planet is good for life. Spectroscopy is used to find these gases by breaking up light and looking at the patterns. The JWST is great for this because it's out in space, away from Earth's air. It's hard to get time on the telescope, so K2-18b must have looked really interesting to get a slot. Now, some scientists are guessing that K2-18b could be a water world, with huge oceans under a thick hydrogen layer. If these water worlds are common, life could be more common too. On Earth, life can survive without sunlight, like on the ocean floor near hot vents. If K2-18b has similar conditions, there could be ecosystems powered by chemicals. But again, we have to be careful. The ocean on K2-18b might not be water. It could be something else, like ammonia or methane, under high pressure. The planet is also really cold, about minus 48 degrees Celsius, so we don't know what kind of liquid could exist there. Also, the gravity is much stronger than on Earth. Any life there would have to be very different. Even if there's an ocean, the air is probably not good for humans. It's full of methane and carbon dioxide. But that doesn't mean there's no life. It just means we're more likely to find tiny creatures. K2-18b is also pretty big, about 2.6 times wider than Earth and 9 times heavier. That puts it somewhere between a super-Earth and a mini-Neptune. This affects how scientists think about its air, pressure, and inside. We don't even know if it has a rocky surface. The biggest problem is how far away it is. K2-18b is 124 light-years away, which is trillions of miles. It would take over 1 million years to get there with our current rockets. We can't send anything there anytime soon. So, we have to use telescopes like JWST to learn about it from far away. Even though we can't visit, astronomers are still excited. Each time the planet passes in front of its star, we get another chance to study its air. By watching these passes, we can get better at finding tiny patterns in the light that might tell us about the planet's chemicals, clouds, and oceans. Not everyone agrees about what kind of planet K2-18b is. Some say it's a water world, with lots of liquid under a heavy atmosphere. Others think it's more like a mini-Neptune, a frozen planet with thick gas and not much chance for life. This is important because a mini-Neptune would be a harsh place, while a water world could be friendlier to life. The different ideas come from how scientists understand the data. The size, weight, and air of the planet can be understood in different ways. For example, if the hydrogen air is too thick, water might not be able to form. But if the pressure and temperature are right, there could be oceans hidden under the clouds. Scientists are also checking if the DMS signal could come from something other than living things. On Earth, DMS comes from sea plankton, but other planets might have weird chemical processes that make similar gases. Since Earth is the only planet we know with life, we have to be careful. We need really good evidence before we can say we've found life. The scientists studying K2-18b have been clear that their findings are not final. Some even worry that the DMS signal might disappear when they get more data. Telescopes can make mistakes, especially when looking for tiny signals from so far away. That's why they need to collect more data and have other scientists check their work. If the DMS signal stays strong, they'll need to figure out if it could come from non-living things. If not, then it's more likely that it's from life. The chemicals in K2-18b's air, like methane, carbon dioxide, and maybe DMS, can tell us a lot about the planet. On Earth, methane comes from both living and non-living things. But when it's found with other certain gases, it can give us a bigger picture. If the mix of gases seems like it could support life, then the planet is more likely to be habitable. The fact that the telescope is in space gives us the ability to check distant planets, but telescope time is restricted. K2-18b got its place under the JWST's lens because the first data was interesting enough to justify spending time on it. As they found results, a theory came up that maybe K2-18b could be a water world, a kind of planet covered in hydrogen-rich air, with a sea underneath. If that's true, there's a huge amount of possibilities. In theory, these kinds of worlds could hold alien plankton, or some other sort of sea creatures changed to wild conditions. Earth's seas have taught us that life can be okay even in complete darkness and insane pressure, some of which are at the bottom of our deepest trenches near hot vents. If similar sources of heat exist on K2-18b, like underwater vents powered by inside heat, then they could give stable spots for microbial systems. But water isn't the only thing needed to guarantee life. The sea on K2-18b might not even be water in the way you'd think of it. Some versions say that ammonia, methane, or other stuff could work as liquids under extremely high pressure and low temps. In point of fact, one of Saturn's moons, Titan, has methane lakes, showing that liquid doesn't always mean H2O. Temp guesses for K2-18b make stuff even more hard to understand. The planet may float around minus 48 degrees Celsius, which would normally freeze water. On the other hand, high air pressure could keep certain liquids in a stable state. That said, people that may visit, if that was ever a thing, will find the air to be very dangerous. Its air, made up of a lot of methane and carbon dioxide, would be poisonous to us. But for scientists, habitability doesn't mean being nice for people. It only has to have conditions where life could survive in some way. K2-18b is often compared to some cold moons in our own solar system, like Europa, which goes around Jupiter, and Enceladus, which goes around Saturn. Both these moons have ice water-covered oceans, and may have life systems under the surface. Even though they don't have thick air made of hydrogen, the idea is kind of similar: life protected under layers of shielding, maybe in warmth near hot activity. And K2-18b's, if there's alien life, it might live far inside its sea layers. Some scientists imagine depth-based systems with tons of microbial life, or maybe bigger sea animals changed to deal with crazy pressure and darkness. Still, there's always a decent chance K2-18b is more of a water and ice-filled mini-Neptune, a planet so thick and gassy that life, in ways we guarantee, might not be possible. K2-18b is about 2.6 wider than Earth, and roughly 9 times larger. That kind of size brings crazy pulling power which would harm any animal's biology living there. If life does in fact exist there, it would most likely look almost nothing like life here. These mysteries place the planet's place to be in the middle of a couple types. Too big and thick to be a copy of Earth, but too much going on, and layers to not call it guaranteed a gas giant. Distance is still the hardest wall there. K2-18b is roughly 124 light-years off, or roughly 700 trillion miles. With spaceflight tech that we currently use, it'd take over 1 million years to make it there. Even robots from our fastest projects would need tens of thousands of years just to come close. The closest star system, Proxima Centauri, sitting at 30 times closer than K2-18b. That makes any visit untenable given what can be done now. However, people in space aren't letting up on the idea though. They are still doing remote sensing with tools like the JWST to take notes and find clues, which continue to get better. Long distance is now being steady, one must hold on. Every planet view, every chemical noted, every new thing told, all that gives a better picture of what K2-18b is maybe. For those that find that journey too much just because it's so long, in theory, people who study space have ID'd other planets that are closer to our home. In the distance, these people have made closer points to use for future seeing, or robotic missions if much time goes by. 2 on the list now, Proxima Centauri b and Ross 128b. Proxima Centauri b is only 4.2 light-years, an ideal place since it's inside the Alpha Centauri area, the closest space to Earth. The issue is, just because this planet is much closer to K2-18b, it'd still require fast vehicles to still be traveling in for tens of thousands of years. Still, the distance that it takes makes it more practical. The planet roams a red dwarf, kind of like K2-18b. The sad part is red dwarfs are way smaller and less strong, since zones which are practical for life will need to sit close to the star, and because of that, get touched by flares and radiation. It has been questioned if it can be protected by this with its own solid magnetic shield, or a thick wall of air. People are still on the lookout. Ross 128b has another cool chance. Sitting by about 11 light-years off Earth, this is near to a red dwarf, but a red dwarf which is less crazy. The good news here is radiation and flares won't be hitting it a lot. Ross 128b rolls closer than Earth, but still will see the same warmth given how weak their star is. Numbers point out conditions may be ideal: 23 degrees Celsius, 73 degrees Fahrenheit, a win for what we like to think. But many of the issues are the same for other planets. Atmosphere, magnetic shield, water-filled clouds are still not checked yet. The 2 listed are still being checked with tools, such as the see-through tool and image tools. Some parts need to be worked on, but they should progress. Hopefully we can draw out what their air wall is, and check what chemicals can give clues, such as extra gas combos with oxygen, methane, carbon dioxide, or less heard of stuff to that effect. Because what's around it for distance is way easier to see than K2-18b, that means there's a solid amount of possibility there. But the one that made the show for us, K2-18b, is a planet which has kickmules which made the show. If the atmosphere turns over a brand that sounds like it has life in it, that makes their planet pop off more than other 5000 plus on the chart. The great part is if there were to be even stronger signals on other planets, maybe even the closet ones, this will push scientists. This newfound light would push scientists to look for some sort of mission, generational mission perhaps. Apart from planets, the search of this entire planet, Earth, is getting way more ground. Even a planet such as K2-18b holds clues. People believe with those clues, the higher odd we will find other species in this galaxy. Since planets like K2-18b, which is rolling near red dwarfs, are 75% a part of Milky Way. Some stats said if any hold life, it will pop on billions of charts around. However, it needs to be taken on the fact in the correct space for water to sit still does mean that life exists. It means it could possibly exist. We are going to see if other locations such as our known solar system can hold it too. This way what could have been a chance turns into true chance of life.